Hi everyone, this is Emily. In this recording we're going to work on basic hydrolysis for amides. I know in a previous recording I did acidic hydrolysis, but I wanted to do this one as well because this one's pretty different from the acidic version because they both have their kind of own two products that come with it. So we're going to go ahead and get started. So the first thing we do, like we did with acidic hydrolysis, is we have to add water to this compound. Okay, so I'm going to go ahead and add H2O. And here, again, you always want to break between that double bond O and that nitrogen. Okay, so I'm going to form my two compounds. And my OH is always going to go to that carbonyl. Right, and then my other H is going to go to the nitrogen. Alright, and remember, if you have less than 3 things around that nitrogen, you have to put in however many hydrogens you started with. So this one I had 1 to start with, because I have to have 3 around that nitrogen. Okay, so that's this one here that I drew. Okay, and then this hydrogen I added from the water. Okay, so once I have that, I have 2 products, so I can only add my LiOH to one of them. So because LiOH, because that's a base, I'm going to add that to my carboxylic acid. So I can't add it to my amine because it's also a base. So remember we said that bases and bases can't react and acids can't react. So this can't have any more done to it. So that's going to be a final. And this LiOH is going to hook onto this carboxylic acid. So when you do that, it's a little tricky because here we added water to get this product, to get that carboxylic acid, but we have to take it off again. We have to take off water in order to get this LiOH hooked on to that carboxylic acid. So what I'm going to do is I'm going to pull one of my hydrogens from that OH because I want to get this O by itself, because when that O gets by itself it gets a negative charge. Okay. And then over here, I'm going to pull the rest of my water from that OH that has that Li hooked on it. So once I do that, Li turns positive because OH is always a negative ion. Okay. So what I'm looking to do is I want this Li, I want it to hook on to this oxygen. Okay. So because the Li is positive and the O is negative, they can do that. All right. And we talked about the positive negative, how that means we have a salt. So this here, this is actually a carboxylate salt. Okay, so in terms of naming it, you always start with naming your metal first, so your cation. So I'm going to start with lithium. Okay, so you'll notice this is a little bit different than how we did the amine salts. Okay, so we have lithium, and then the ending is pretty much like an ester, so that's good. Nothing new there. Okay, so here we're just going to close it out with lithium butanoate. Okay, so our 2 final products are going to be this lithium butanoate that we have here, and then over here that amine that we started with, so that would be called ethylamine. Alright, and there we go. If you have any more questions about this, you can always talk to me in SI sessions, or if you're kind of stuck on the acidic version, you can refer to that other recording. Thank you.